Yes, today I want to remind you of work, energy, and power. And remember, we say the work done is always product to the force, the displacement, and the cos theta, where the theta we say is the angle between the displacement and the force. And for us to summarize it in this very short video, remember, if you are calculating the work done by the normal force, it's always the normal force, displacement, cos theta. In this very case, remember that theta is always 90 degrees and cos theta is 0. So normally the work done by the normal force is 0. Also, the work done by frictional force will be the frictional force, displacement, cos theta. In this very case, remember that the cos theta here is 180 degrees and cos 80 is minus 1. Cos 80 is minus 1. Remember that. And also the most important one, also this one is common in exam, the work done by gravitational force. Remember, it's gravitational force, theta, cos theta. And in this very case, it depends. The easiest way I will summarize it is this: if the object is moving upwards, this theta will be 90 plus theta. Remember that if the direction of this is upward in an inclined plane, you say theta is equals to 90 plus theta. But if it is moving down the plane, use theta as 90 minus theta. Remember, this theta is the angle of inclination, of the inclined plane. What do I mean? Allow me to expatiate on this one. Remember, if we have S, I said if this is the direction of the displacement, use this one. And if the direction of displacement is downwards, use this one. As simple as that. I don't want to bore you with a lot of trigonometrical relationships. Just take note of that. If it's moving up, use 90 plus theta, and the other one 90 minus theta. Okay. And also remember that in this in calculating the work done by gravitational force, remember, we can also use this equation, change in potential energy. So in other words, if you are not given enough information here for us to use this formula, remember this one, that we can also use this method to calculate the work done by gravitational force. And where this one is mgh, the gravitational potential energy. And another one also which I want us to discuss will be, remember, most times we will always be given that the object is in a constant velocity. Most times we'll be given that an object is in a constant velocity. So anytime we are given that an object in a constant velocity, remember, we have to make the network. The network done will be 0. The acceleration will be 0 meter per second squared. And also the network done will also be 0. Take note of that. Whichever one that applies to you and whichever one that will be more convenient to you, use it. So anytime you are given that the velocity does not change, in other words, the initial and final velocity are the same, know that the network will be 0, and the work done by network will also be 0. So take note of this information because you're going to need it in calculation one way or the other. And another thing I will not forget here is to make mention of various ways we can calculate the work net. In this topic, there's no way you can avoid calculating the work net. There are various ways in which you can calculate that depending on the information we are given. And the very first one is the most common one, work energy theory is equals to change in kinetic theory. The network done is equals to change in kinetic kinetic theory. That is the most important one. And remember, sometimes we may be restricted by choosing any of the method. But if the question is free, depending on the question, if the question did not restrict us from choosing any of the method, we also do that. Remember, another one is this: we can also calculate the net work done by calculating all the work done by those forces. In other words, we can say if there is frictional force, we can say work done by frictional force, the work done by the net force, the work done, if there is applied force, then work done by the applied force, on and on and on, depending on the force. Remember, we have to draw the free body diagram. From the free body diagram, we know all the forces that are applied, that are applicable to that question. So we can use addition of all of them will give us the net work. The change in kinetic energy will also give us the net work done. And also, the last but not the least, remember, sometimes you might be asked to calculate the net work done, where I'm using the original equation, multiplied by cos theta, where the theta is the angle between this displacement and this force. So these are the most important equations which we are going to take note in this topic, how to calculate the net work done. So depending on the kind of question you're given, you'll be able to make choice and choose which of the equations that you are going to use. And another important thing we also have to mention here, remember, if we are given that the object is that the force is applied on a frictionless surface. If the force is applied on a frictionless surface, in other words, if it's in a frictionless surface, we are saying that the law of conservation of mechanical energy should be applied. Remember the law of conservation of mechanical energy? We are saying in an isolated system that the total mechanical energy is conserved. And the total mechanical energy is conserved provided that the system is frictionless, provided there is no frictional force acting on that object. And in that very case, remember, this is when we use the first top is equals to bottom or any other point. But if there is frictional force, if there is a friction, in other way, the surface is rough. If there is friction, in other way, the surface is rough. Remember this equation? We can use the work done by a non-conservative force is equals to change in kinetic energy plus change in potential energy. And I think this is the most important thing I just want to remind you of. I'm not forgetting work done by an applied force. I'm not forgetting work done by an applied force, and I also want to say something on that, work done by an applied force. Let's say, for example, we are given an applied force. Remember that anytime we are given a force, remember, if we have an object and there is an applied force acting at an angle, the first thing we need to know, we have to resolve that force at an angle. Remember that once we resolve this force, this is applied force. Remember, if we resolve this force, we are going to get F cos theta along this line. If you resolve here, we are going to get F sin theta. Always bear that in mind for the case where the applied force is acting at an angle. If it's acting at an angle. So in other words, if we are given the equation, the work done by an applied force, if you are asked to calculate the work done by an applied force, you can easily say it is the applied force, the displacement, cos theta. In this very case, you can use this theta directly. If it is given, you can easily use that theta directly if it is given. If it's not given, then you can, one way or the other, the question must formulate in such a way that you must use it in order to calculate it.